Hi, I'm Bailey with MyMathExperts, and today I'm going to help you solve the following problem. What are the vertical and horizontal asymptotes of f of x equals x squared minus 9 over 16 minus x squared? So first thing, we need to figure out what those words mean. What is a vertical asymptote? Whoa. Hold on, let me just type that instead, actually. That'll be easier. That is a vertical line that the function approaches but never touches. That's what the word asymptote means. It means your function approaches something but never touches it. So for example, if we had a vertical asymptote at like x equals 1, that would look something like this. Usually it's denoted on a graph by a dotted line. And our function might look something like this. You can see how our function is approaching this vertical asymptote, but never crossing it. We don't have something like that. So that's what a vertical asymptote looks like in its definition. So now we need to figure out, how do we find where a vertical asymptote is if all we're given is a function? And the way to do that is we find out where the denominator equals 0. So to find a vertical asymptote, set denominator equal to 0 and solve for x. And the reason for this is that when our denominator is 0, our function value is going to be undefined. So we know that you can't divide by 0, meaning that you're not going to have a function value. It's undefined. So we are going to set 16 minus x squared equal to 0. And then what we can do is add x squared to both sides. And then we can square root both sides. Really, really super important. Whenever you square root both sides in an equation, you actually get 2 answers, plus or minus whatever your answer is. And that's because what we're trying to answer is, okay, what number squared equals 16? Well, 4 squared equals 16, but negative 4 squared also equals 16. So you need both of those answers. So we can see that now we can see that we have 2 vertical asymptotes at x equals negative 4 and x equals positive 4. The next thing is a horizontal asymptote, which, as you can imagine, has a very similar definition to a vertical asymptote. It is a horizontal line that the function approaches but never touches. I'm going to make a note here that says specifically referring to end behavior. Because there are a couple of weird situations where a function can cross a horizontal asymptote, like in the middle, but as you go to infinity, it doesn't cross them as you go to infinity and as you go to negative infinity. So a horizontal asymptote would look something like this. I'm going to modify my graph here. And we'll say y equals negative 3, for example. So that would look kind of like this. And we could be approaching it. We could be approaching it. Over here, you can see that we're approaching but never crossing our horizontal asymptote down there. Horizontal asymptotes have some pretty complicated rules, so we're going to take a little bit longer on this. I'm going to be honest, I have to look these up every time. You probably are going to want to ask your teacher if you have to memorize them or if you will have them listed on your tests. So this is kind of generally the rules for this. The main thing that informs horizontal asymptote behavior is what's called the degree of the numerator and the degree of the denominator. So the degree is like the highest power of x in the numerator and denominator. So to find horizontal asymptotes, check the degree of the numerator and denominator. We can see from this handy little diagram here that if the degree of the numerator is less than the degree of the denominator, there's a horizontal asymptote at y equals 0, which is the x-axis. If the degree of the numerator is greater than the degree of the denominator, that means there's no horizontal asymptotes. And if they're equal, that means we have to move on to kind of step 2 here. So let's see here. Something else I want to mention really briefly is that even though this guide says there's no horizontal asymptotes if the numerator is greater, there could be a slant asymptote. A slant asymptote occurs when the degree of the numerator is exactly 1 greater than the degree of the denominator. So like if you had like x cubed over x squared, that would have a slant asymptote. I'm not going to get super into that because not all math classes actually teach that in my experience. So that's kind of a whole separate thing. We're not going to get into it. Ask your teacher if you need to know about slant asymptotes or not. However, our situation here, we can see the degree of our numerator is 2. The highest power of our x is 2. On our denominator, the highest power of x is also 2. So we are in this middle situation where our degrees are equal. And so our horizontal asymptote is going to be the ratio of our leading coefficients, which is basically just the coefficients in front of both of our x squared terms. So our coefficient in front of regular x squared up here is just 1. There's no coefficient, so it's just 1 times x squared. And then our denominator, there's also no number in front of our x here, but it is negative, so that's going to be a -1. So our equation of our horizontal asymptote, when we simplify 1 over -1, that's just -1, is y equals -1. So we know that our vertical asymptote is at plus or minus 4 equals x. We know that our horizontal asymptote is at -1 equals y. Let's see if those, yep, it looks like A is an option there. X equals plus or minus 4, y equals -1. Last thing I want to touch on here, it is really important that you phrase these as x equals this thing, y equals this thing, because these are lines that we're representing. If you just say like, oh, my horizontal asymptote is -1, I don't know if you mean x equals -1. I don't know if you mean y equals -1. I don't know if you mean like the coordinate point 0, -1. So you really need to phrase these as full mathematical sentences with equal signs as like x equals or y equals. So great. Thanks for hanging with me there. You really just kind of have to memorize these rules and practice with them. There's plenty of practice out there if you look for it. But thanks for following along. I hope that helped.